All right. Hi, everybody. Can you hear me in the back okay? Awesome. So my name is Jordy Anderson. I'm a security solutions architect with Amazon, based here in Ottawa. We're also going to have Sean Donaghy and Mike Davey from the Canadian Centre for Cybersecurity coming up to present as well. Going to be talking to you today about how to lock down your AWS accounts. Just so everybody's aware, you're in the technical track, so we're going to talk about awesome stuff like this. If you don't want to look at this, there's the management track and the spotlight track in the other rooms. So I'm going to start off with just a few basics on AWS here. In the last session, there was a lot of coverage on some of the AWS services, so the focus here today will be getting into a lot of automation. Just a few basics. No AWS session would be complete, especially a security session, without talking about the shared responsibility model. So I'll just talk briefly about this. You can see the line going across here. So we say that AWS is responsible for the security of the cloud, but as a customer, you're responsible for the security in the cloud. That line, from an infrastructure perspective, think of that as the hypervisor. So everything hypervisor and down, AWS is responsible for. Everything hypervisor and above, you as a customer are responsible for. Now, the interesting piece of this is that this line can move up. So moving from infrastructure services here up to what we call container services, this is where AWS is managing more of the service for you. So an example here would be our relational database service, where you get basically an SQL endpoint, and AWS is managing the operating system and all the replication under the covers. And then evolving from there up to what we call abstract services. So this is where AWS is managing most of the service. So examples here, things like S3 or AWS Lambda, where you're basically just bringing the code and you're responsible for the code sanitization. So when you're thinking about the responsibility model, also think about what service it is that you're using. A few other basics here, CloudTrail. So CloudTrail is your audit trail in AWS. So whether you're clicking in the GUI or using an SDK or using a CLI or maybe a REST-based API, however it is that you're interacting with AWS, it's going to get recorded by CloudTrail. So the who, what, where, when, what was the response as well. And then all of that is logged in S3, in our simple storage service. So you as a customer get to decide how long you want to keep that data. Do you want to keep it for a day, for a month, for a year? Do you want to archive that off into Amazon Glacier? You have that choice. Another key thing under the covers, I'm going to build on some of these, so I'm just sort of introducing them here, is VPC flow logs. So VPC is our virtual private cloud. This is our layer 2, layer 3 networking, software-defined networking. And basically, in VPC flow logs, you're going to get all kinds of information about every flow. And this is like NetFlow. If you've used NetFlow in the past, similar kind of idea, a one-liner of what's described in the flow. You can turn this on at different context layers, so at the interface layer or the subnet layer or the VPC layer. This also gets stored in S3. So you as a customer have the choice as to whether you want to keep that for a day, a month, or year, archive that off into Glacier as an example. Now, as we get a little bit more into some of the automation here, AWS has teamed up with the Center for Internet Security, the CIS, and we've created a benchmark. So this is like an automated hardening document, so to speak, that you can use to make sure your AWS accounts are secure. On AWS Labs now, you can download an open source package, and this package will basically go out and it does the CIS benchmark against any AWS accounts that you have. So really neat, you can automate it. This one here is in just on the Unix command line, on a Linux command line, 3 lines to run it. You could also drop that into a Lambda function if you wanted to and automate this. So it could run every day or every hour, whatever you choose, to check your account for these particular things. The output of this, lots of different options here. So in this case here, the output is a sort of red light, green light kind of HTML report. One way of doing it. This is good for leadership or maybe something you might want to send out in an email. Another option is something like this, where you're actually dumping the raw JSON. So in a raw JSON format, something downstream, like maybe a Lambda function, could do some sort of post-processing with it. Or maybe a downstream SIM server of some sort would do something with this particular information. Because it's open source, you can also refine it even further. So something like this here, where we're only really looking at the particular benchmark items that failed. So depending on your downstream processor, you can basically decide how you want that format to look. You'll be able to download the slides after, so just including a few other very interesting software options here in this space that you can check out as well. Okay, so let's talk a little bit about patching now. This picture is from the US Navy. They run an exercise on their ships periodically to basically see, it's a bit of a competition, basically see who can make the most effective, what they call soft patch. So you can see these folks here using, looks like rope and Band-Aids and duct tape. This one's not working too well. But how do you do patching in the cloud is a question I often get. So this is where I'm going to talk a little bit about AWS Systems Manager. So this is how you can do patching at scale. Systems Manager, there's no actual cost for it. It's just an overlay, a software overlay. You just pay for the EC2 instances or whatever you're actually managing underneath it. The way it works is by a lightweight agent that you install on the operating system, and it's available across diverse different operating systems. So the way it works is you basically define what we call a patch baseline. So a patch baseline can align to whatever your organization's security posture is. Could be, I want everything patched right up to the moment. Or I want to create a baseline that's going to be just a particular package or just a particular version. So you decide what that baseline is, and then from there, when Systems Manager runs, you'll basically get an output here showing compliant or not compliant to that particular baseline. And then from there, you can trigger automated patching for those hosts. Now, going a little further in Systems Manager, another interesting piece in here is the run command. This doesn't get a lot of attention, so I wanted to talk a little bit about it today. It's a subtle feature, but it's very powerful from a security perspective. So to give you a bit of an analogy, I'm going to take you back to the 90s here. This was the picture I've used to describe a movie that happened back in the 90s that had a bunch of dinosaurs in it. It took place in some sort of a park. From what I remember, it was a very Jurassic type of park. In that movie, one of the characters gives a perfect example of an insider threat. So I don't know if anybody remembers this. There was a disgruntled employee that basically ran some malicious code and then tried to cover his tracks, and he ran a command called White Rabbit. So then suddenly, all the gates fly open, chaos ensues, there's velociraptors out there attacking everybody, terrorizing people everywhere. And then that led to workplace safety posters like this, likely pinned up in the lunchroom. Now, back to the real world. So taking this sort of insider threat, one of the challenges in using SSH and RDP is trying to document and track who's doing what from an identity perspective and what OS commands they might be running. Especially as you get into higher security environments. You've got to worry about things like the insider threat. So one recommendation here is you can use the run command rather than using SSH and RDP, especially for a high security environment. Everything that the run command will do will be fronted by an AWS API. So you can basically run your command. It'll get triggered by the run command down to the EC2 instance. The powerful part of this, and if you're a security practitioner, this should interest you, is that every command gets logged into CloudTrail. So this is, again, a subtle feature, but a very powerful one. And then that'll get recorded into an S3 bucket. So this is fantastic, except what if our adversary, the evildoer, has access in this account to that S3 bucket, and he wanted to cover his tracks. So to take this a little bit further, we could not log the S3 bucket in this account, but create a separate security account and drop the S3 bucket in there. So this way, all the admins and the users that are actually executing the OS commands on the left side have no ability to access the S3 bucket and try and change or cover their tracks on the right side. The central security account is a best practice that's going to come up as a bit of a repeated theme in this presentation. So this is a best practice here, central security account, and logging off to another account. Now back to the systems manager. Another interesting piece in here is the session manager. And we introduced this I think it was only about a month ago. And this is not quite as extreme as using the run command where everything has to go through an API call. What the session manager allows you to do is actually launch an interactive shell, whether it be on Linux, on Bash, or on PowerShell on Windows. So you get full access control here. So maybe not for a super high security environment, but maybe sort of a medium security environment or dev environments where you really want to track what people are doing. This is a way of still giving people the interactive shell that they want, but having every single command logged into CloudTrail. A lot easier to use something like this than trying to figure out how to do that across diverse OSs in a central sort of way. Another service is guard duty. I'll just briefly talk about it. Guard duty takes feeds from three things. So VPC flow logs that I already talked about, EC2 logs, EC2 DNS logs. So there's a wealth of information that we get in DNS logs in terms of what the EC2 instances are talking to. And also CloudTrail logs, so who's doing what from an API call. And it will do this across multiple accounts. So it's multi-account aware, which is fantastic. That'll be another theme here in this talk, is being able to do things at scale across multiple accounts. Now, all of that gets combined in with a threat intel feed coming from Proofpoint, from CrowdStrike, and AWS security. We combine all that together and use machine learning algorithms to look for anomalies. So it's a lot more powerful than just sort of static if-then-else type coding here. And this is how we can detect a lot of really interesting things, by using the machine learning. Then, once there's some event that is of interest, downstream you can use CloudWatch or Lambda function and send that down to something like maybe a global SOC. So I've seen integration here with things like Slack feeds, real-time Slack feeds in a SOC, integration with downstream directly with routers that have API front ends, could be a downstream SIM server, some sort of central SecOps workflow perhaps as well, other options. Now, some of the guard duty detections, sort of break them up into three categories here to give you a bit of a view in terms of what guard duty is tracking. So first of all, on the EC2 side, because we have the DNS logs, and we also have the threat intel feed from CrowdStrike and Proofpoint, we can see who your EC2 instances are talking to, and when they're talking to something evil, like things on that list there. From a recon perspective, lots of interesting information here. So APIs invoked from malicious IPs. Is anybody doing anything from a CloudTrail perspective? We'll be able to see if it's coming from from a Tor exit node. Probably not a good thing. Port probes, SSH, RDP, brute force attacks. That's going to be constant from the outside, so not as concerned about that. Any host you put out there is going to get hit fairly heavily immediately. But we're also looking outbound. So from the inside, your EC2 instances and private subnets going outbound as well. So sometimes you might have an instance that's been compromised that's talking to some sort of a CNC server out on the internet. We'll detect that as well. And then lastly, IAM is identity and access management. Lots of interesting things here. We're looking for any time there's changes in CloudTrail. That's a red flag immediately. Something's wrong if someone's changing things in CloudTrail. But the stuff at the bottom here is where the machine learning comes in and shines. Unusual IAM changes, unusual network changes, unusual resource changes. Different ways of looking at stuff here. If user Jordy is in the system and I do no network changes for a long period of time, and then suddenly I'm opening up VPCs to the internet and creating all of these connections out, that's an anomaly. So that's the kind of thing that'll get flagged and that someone might want to take a look at. So now moving this a little further into automation. So this is what I call my guard duty kill chain. Starting with guard duty, moving across to CloudWatch, and then to a Lambda function. Very easy to set up. So here's a view of the actual CloudWatch rule, and it's only a few lines of JSON there, and you put that in to basically say, okay, I want CloudWatch to ingest all the guard duty detections that are coming down. Next step, Lambda function. This is a very basic one. Not very long, it's only 8 lines. What detection are you interested in, or detections? So this one's in Python. You can put a couple of detections there that might be high severity events that you're interested in, and then do something here. So you get a lot of choice here, and you need to think about what you're going to put in for the do something here. So adding on something onto the end of the chain now, where we have an EC2 instance. It could be that we want to block the source that might be sending something evil in. Maybe it's coming in from the internet. Maybe we want to, if it's an internal source that's doing all this, we want to disconnect the elastic network interface of that instance. We don't want to turn it off. We want to be able to look at what it's doing, but disconnect its network interface. We could disconnect the network interface of the destination host as well. So lots of different options here in terms of what you want to do, and that will depend on your security posture in your organization. So then we get into rethinking incident response in the cloud. When we go back years ago into the on-premise world, back in what I called the BC era, before cloud. BC is before cloud. So back in the BC era, if you had a host that got compromised, you would typically walk in the data center, pull the clips, RJ45 out, and then maybe that host would make its way into an isolated lab or something like that to do some forensics on it. In the cloud, works a little bit differently. So everything can be automated. So let's say you have some hosts that are in a production security group. These could be web servers, could be anything. One idea here is to build an isolation group, either a security group or a subnet for forensics investigations if anything got compromised. You can build all of your tools in there, and even better, take it a step further, put all of those tools into a CloudFormation script so you can launch them automatically, triggered on demand as well. When you have an incident then, everything's ready to go. You can go investigate quickly. So bringing back the kill chain here, one option here would be to have that Lambda function, upon detection of some high severity event, send an API call, because everything's API based, and logically move, by changing the security group, that instance into the isolated security forensics subnet. You could also then call the CloudFormation template to fire up your tools, send you a notification and go, hey, this host has been moved in here, need to take a look at it. Now, we've probably all seen a data center, something like this. I always try to put a picture into presentations with awesome data centers. This one's even better. I found this one, and I don't know if it's clear for you guys, but right over here, there's actually a black mat that's been put down on top of the cables for them to walk back to that half rack at the back, this is like top 10 material right here. That's awesome. So in a traditional data center, things like visibility and accountability can be problematic. There's always some unknown cables tucked around the corner, unknown servers that nobody can account for. So this is where you can use things like VPC flow logs in the cloud. Nothing can be hidden anymore. Everything is visible. You can see where things are, being plugged into. So one example here would be, say you're running a compliance application of some sort, and that compliance application is on a private subnet. You can record the VPC flows across that VPC, and then set up custom metric filters. So in this case, maybe looking at SSH and the number of rejects that we're getting. Keep in mind, this is an internal subnet, so there's no outbound connection here. If something is trying this thing and rejecting SSH, it's probably not a good thing on a high sensitivity internal subnet. We can then set up an alarm downstream from that, saying if the SSH rejects are greater than 10 or 20 or 50 or 100 or whatever makes sense in your environment, just an example here, then do something. Send it to SNS for a notification. SNS is our simple notification service. Send it to a Lambda function to do something. So this Lambda function could maybe disconnect the source IP that's sending these requests for investigation, move it into that logical forensics subnet, as an example, disconnect the destination server if it was found to be compromised. Lots of different options. The neat part about Lambda here is you don't have to do just one thing. So you can do multiple things. After the code finishes to actually move this server off or disconnect it, we can run a second set of code in that Lambda function that would auto-cut a ticket and notify admins. So if you use a downstream ticketing system that has a front-end API on it, that is fantastic for this kind of stuff. Lambda can trigger that automatically. We already know from that source from the event that happened, we know the source, we know the destination, we have the details, we know the automated remediation that was executed, we know the response from that remediation. We can put that all into the ticket. So nobody has to wake up at 3 in the morning here. The instance can be isolated, data filled into the ticket, someone comes in the morning, and then they can look at it, and all the data's there, ready to go, all documented. So now I'll talk a little bit about how to do this with IP range blocking. So let's say you have a threat intel feed of some sort. This could be from a third party. You might subscribe to a third-party threat intel feed. This could be your own threat intel feeds coming from your sort of security edge telemetry. Whatever it is, take that and let's say you put it into a file, and that file sits in S3. So you've got a central file for all of your security IPs that you want to block, a blacklist, let's say. And maybe this changes every hour or every day or whatever that cadence might be. Let's say every hour. You want to be able to take that IP file centrally and push it out to all your resources to put those blocks into place. So this is actually very easy to do. On S3, what you can do is turn on what we call an S3 event notification. So the S3 bucket here is actually set up to listen for any changes on that file. So it could be an update on that file. You decide what the update will be. Could be an update, could be a new file, could be a delete. You choose what the trigger is. S3 can then call SNS. So SNS is great for pub-sub kind of work. And then from there, you can have a Lambda function that subscribes to that SNS topic. So the Lambda function is essentially sitting there listening, waiting. And then from there, your Lambda function will pull the updated file and then maybe update a security group on your load balancers. So one example here, if you're using application load balancer or classic load balancer. Same idea if you're using a WAF, a web application firewall, as long as your WAF has a front end with an API, or your firewall has some sort of front end with an API. I've seen that as well, where this kind of automated chain can basically apply updated threat feeds from a central file out to the perimeter. So you could take that notification from S3 directly to Lambda. You don't have to use the SNS topic. The reason I've put the SNS topic in there, it's intentional, is because I want to show you how you can use SNS, taking this a little further into a multi-account structure. The pub-sub model makes it a great tool for doing that. So here's a view following a best practice of setting up a central security account. We've got our IP threats file with some threat intel that's kind of updating it maybe on an hourly basis. We've got our S3 bucket. Now we've on the left here got 3 other accounts, 3 separate accounts. These are workload accounts running separate workloads of some sort. In those accounts, I've got SNS sitting there listening. So the way this will work is there'll be some sort of an update on that file. Same as the last slide, it'll basically call the S3 event notification. There's a new object in that bucket. That will trigger across to the SNS topic. The SNS topic then, because the downstream topics in the other accounts are essentially listening, this is how you can project stuff out across multiple accounts. So that will push down. Took me about 20 minutes to make that animation. Pretty awesome. That will push down to the end SNS topics or responders at the other side on those accounts, trigger the Lambda function, which will grab the latest file, and then update the IP ranges that you want in those individual accounts. So this is a nice way to do it from a central single file, controlled and only accessed by the security folks, that you can then push out across your entire network in a multi-account strategy. So how do we make people do things that or do only things that we want them to do? So getting into compliance here a little bit. So you can use tools in AWS like AWS config. So config records what's happening on your system. It's like an inventory. Any new systems that are getting added, it can run rules against them. Lots of interesting stuff you can do here. You can do custom rules. There are canned rules. I'm going to give you a few examples of some of the canned rules in the system. These are very easy to set up, often just 1 or 2 clicks to set these up. And then every new resource that someone might add will get run against these rules, and then you can do something downstream about it. So an interesting one here is S3 public read-write prohibited. Buckets, if you create a new bucket, by default, it will not have public read-write. So someone has to change that. So this is where we can basically get a report and see when someone has added an S3 bucket and made it open to the world. So very easy to do with config. So the config dashboard looks something like this. You'll get a single view of your entire environment. This is multi-account aware, which is fantastic. So on the left, you've got all the resources. You can drill down in that. You can get an enterprise-wide view of compliance here. And then on the right, you've got this dashboard. So if I zoom in on the dashboard a bit here, I just took this from my account. There's a few resources here I've got that don't have encrypted volumes, don't have their RDS storage encrypted, et cetera. So I could take something like this and send it out as a report to people, but I want to take it a little further and automate it. So automated compliance. So going to an automated setup here, we'll use an AWS config rule. We're going to pick the rule for S3 public read-write. And then we're going to send that down to CloudWatch. And CloudWatch, the event, the rule that we'll run is whenever there's a non-compliance, do something. So what do you think we'll do? Send it to a Lambda function, of course. So the Lambda function in this case could be set up to basically reset the S3 access control list to private automatically. And then because Lambda doesn't have to do just one thing, you'll see the repeated theme here. Notify the admins, cut a ticket. Even better, cut a ticket that notifies the end user that owns the bucket as well. By the way, you created something that didn't meet compliance policy. We've reverted it, and you now have a ticket against you or whatever. So lots of interesting things you can do with config, and very easy. Now let's talk a little bit about access control. So one of the interesting features in AWS for access control is the Access Advisor. So don't talk about this too much, so I want to bring it up here. If you go in and look at any particular user or role in AWS and drill down, you'll see this Access Advisor tab. And it's going to show you here a bunch of interesting information, the service permissions that are granted to that particular user or role that you're looking at. And the interesting piece is on the far right, when was that last accessed? So if you want to claw back permissions back to the principle of least privilege, this is a good way of looking at the data. But all of this data is also held in CloudTrail. So for any developers here that want to do this in an automated way, you've got different options using Amazon Athena. So Amazon Athena is our serverless SQL service. So if you have data in an S3 bucket, like a CSV file or any kind of data in S3, you can actually use Athena to have an SQL interface to query that data without having to dump it into a database. Pretty awesome. Hard to explain, but kind of awesome. So here I could put in a particular target name that I'm interested in an SQL format like this, and I'll get that info back, and I could maybe use that for some downstream automation. So taking this a little further, one of our customers, Netflix, released a couple of solutions in this area. One is called Aardvark. So Aardvark, great name. What it does is it'll basically go into your account, into that Access Advisor information, and it's going to grab all that information, and it's going to put it into a database, and then it's going to put a front-end REST-based API on it. So it's basically an API database of Access Advisor information. So just like the anteater sucking all the ants up, Aardvark is pulling in all of that access advisor information and making it visible with an API front end. Then the next piece of this is RepoKid. So RepoKid, this is not like repo, like repository. It's repo like repossess. So RepoKid will basically use the data that's been harvested by Aardvark to look at all of your users and roles and determine where something hasn't been used or ever used in a long time. That's a very powerful account where you can scale back to the principle of least privilege. Now, it takes a bit of testing and monitoring, so you want to be careful with this, but it can significantly improve your security posture if used carefully. Now, globally, AWS has a lot of regions worldwide. Your workloads can run pretty much anywhere. So one of the common requests that I get is, how can I keep my data in the Canada-Montreal region? So a very common thing. So we want to set up some basic guardrails in the account, let's say. So you can do this with this wall of text. That's how you do it. Bunch of different actions at the top. The line of interest here is the red one. So it's basically defining that for this particular action that's being run, the AWS requested region is CA Central 1. It must match to the Canada region. Otherwise, the request will get denied. So this works well, not just with users, but also with roles. So if you're doing any identity federation, ADFS, Active Directory Federation Services, or SAML 2.0, anything like that with integration to an on-premise Active Directory, you can drop in this policy and restrict users. So now let's talk about when you have to manage a whole bunch of AWS accounts at scale. So we do this with AWS Organizations. And service control policies, or SCPs. So the way this works is you start off with a master account. Any account can be a master account. So you define, this is my account that's going to be a master account. You decide. The master account, you'll then build out some sort of enterprise org in there. These are logical blocks. You decide what they are. I've used enterprise in a couple of divisions here as an example. You build it out, landscape, portrait, whatever, to maybe map to what makes sense in your particular organization. And then you add in member accounts, or sub-accounts, some people will call them. So the member accounts in this case are actual AWS accounts. Anything in the solid yellow box is a real AWS account. The division, and enterprise thing with just the outline are only logical. They're not real accounts. So the reason for this is SCPs, the service control policies, can be applied at each layer. So this is how you can implement control across a large organization of AWS accounts. Service control policies are broad in nature. So think, like the name implies, service. Whitelist, blacklist, whitelist EC2, S3, and Redshift. Blacklist, marketplace, whatever services you want to add or remove, or blacklist or whitelist, you decide and you put the policy in. So let's say you do a red policy at this layer, whatever that might be, that will get inherited down through the whole tree. So this is a way of doing one policy that will be inherited down enterprise-wide. Otherwise, if I do a purple policy on Division 1 here, that will get inherited down just to Division 1, and so on. If I do a blue policy on Division 2, inherited down only across the Division 2 accounts. If I want to do something down at the lowest level, I could do a green policy on account 1 there. That will only be in effect on that particular account. A black policy on member 3, whatever that might be, that will only be in effect on that account. So this is how SCPs work. This is one layer of the policy control you can do. The next layer is what we call IAM policies. The policy that I showed you a couple of slides back with that CA Central 1, that's an IAM policy. So service control policies at the top are very broad. IAM policies are very, very granular. You can go in right down to the particular API call you want. You can go right down to a particular user or role. So two kind of different uses of policies here that kind of work together. The SCPs at the top cannot be overridden by the local admin below. So an analogy I like to use here is how things work in a Windows enterprise domain. You'll have some sort of group policy that you can push down from above. You'll have domain admins and local admins. I might have a local admin privilege on my laptop. I'll go in, I'll be able to do pretty much everything, but there might be certain things that are grayed out because that GPO comes from above, from the domain admin. Same kind of idea here. Consider the SCPs that are pushed down above. The local administrator will have access to whatever he can access that's not restricted by the SCP coming from above. So the last thing I want to talk about is landing zone. So landing zone is a solution that we've come out with recently. People that have worked for the last few years with solution architects like myself, I'd work with customers to build a multi-account strategy, how to do it securely. And what we found over time is that the multi-account strategies that we've been building in all these different customers ultimately ended up looking very similar. So what we've done is we've come out with this landing zone solution that will basically build a secure multi-account strategy for you from templates. So there's no charge for the landing zone solution. You only pay for the resources that it manages or what you create as options as part of the landing zone solution. So it looks something like this. Start off with a master account, similar to what I had before. Master account at the top. You decide which account's going to be your master account. In there, lots of interesting things get created. I'm not going to have time to go into everything deeply here, but single sign-on, a big thing that's easy to set up. Account vending machine for sub-accounts or for member accounts. So you can actually go into what we call an account vending machine and create new member accounts. Now, as part of this structure, we also create 3 additional member accounts underneath that are part of this management structure. So first of all, a central services account on the left. This is where you choose the options, but you can set up log reporting if you want using Elasticsearch. Active Directory in there as well as an option. In the central services account, you might build central networking. Things like AWS Direct Connect might fan in to member accounts from there. Central services like NTP, DNS, et cetera. Then we set up a central logging account. The logging account is basically central log aggregation for things like CloudTrail logs. So this is where they're going to go. It's a lockdown account, limited access. And then the last piece we create is a central security account. So the central security account in this case is very powerful, and it's set up with break glass access. Limited number of people should have access to this central security account, and they can get into member accounts and shut things down if necessary. So if I take all this away and zoom this down a little bit, here's sort of what the big picture looks like. Everything that I've described so far is set up one time at the beginning. This is your management structure. This is what the IT folks are going to use to do the central logging, governance, and whatnot. Then below that, you start creating all the member accounts through the vending machine. So the member accounts in this case are all the workload accounts, different projects, different workloads, and whatnot. The neat thing about this is that those member accounts, when you create them out of the vending machine, will be automatically tied back for central log aggregation. So CloudTrail is going back to that central logging account. The cross-account roles that you have in the security account will be able to come into the member accounts in a break glass type access method if required. So this is the landing zone structure. Like I said, no charge for it, just a bunch of templates. You run them, and then you will pay if you choose different options like adding on log search, Active Directory, et cetera. Okay, so in summary, just to wrap up here, these are some of the ideas that I've covered. You can see through all of this that the key theme here has been around automation. It's people that make mistakes. It's people that have good intentions but get phished. It's people that use the same credentials in multiple locations and don't turn on multi-factor authentication. It's people that don't do well with things like repeatability or working under high stress. So this is why we need to leverage automation as much as possible. Automation doesn't mind waking up at 0300. Automation doesn't need to eat, sleep, or have a coffee first thing in the morning. If you leverage automation, things will get done consistently. So I'll just leave you with one quick final thought. And this goes a little more broad beyond just the security benefits of automation. One of the interesting byproducts of doing this kind of automation is that it can act like an employee retention investment. So think about that for a minute. If your security teams no longer have to do all the undifferentiated heavy lifting and all the repetitive tasks, this creates an opportunity for them to learn new things, to innovate, and to experiment, which should mean that their work becomes more interesting, varied, and hopefully more meaningful. So now I'll invite Sean Donaghy and Mike Davey from the Canadian Centre for Cybersecurity up on the stage. Thank you.
Thanks, Jordy. Hi, everyone. Am I on? So today we're going to talk to you a little bit about two different items. I'm going to give a little bit of an overview of what the Cybersecurity Center is, Canadian Cybersecurity Center is, and what we're doing in relation to the cloud and securing the cloud. And Mike's going to do a bit of a talk about some of the work that we've been doing with AWS and some of our partners in academia. So what is our role in government? So traditionally, the Canadian Cybersecurity Center has recently stood up at the beginning of October. Previously, we were 3 different areas within government that had roles in cybersecurity. But we've joined together under CSE, the Communications Security Establishment, and we now have a single unified source of information, expertise, advice, guidance, services, and support to not just the federal government, but also to critical infrastructure operators, academia, and beyond, so all of Canada. So for cloud, specifically, we have 3 pillars of work that we're going to be focusing on. The first is with respect to advice and guidance. So you'll be seeing over the coming weeks and months that, that we'll have advice and guidance that is consumable both by federal government, but as well as all other industries within Canada. So documentation covering soup to nuts of security within the cloud, and I'll provide you with a list of some of the things that we're working on already. The second is assessment. We've talked about that shared responsibility. It's important for us to provide you with advice and guidance on what you need to do within the cloud, but there's also an important aspect of doing assessment of those cloud vendors that are going to provide those services to you, and there's a significant amount of work that's already underway to validate that the folks that are going to be covering the back-end portions, essentially the cloud vendors, of the implementations that you're going to have, that they're doing that in a way that can take care of your workloads securely. So in our case, within the federal government, that'd be protected B workloads, but we're going to have advice and guidance that sort of covers that off for any other industry player that might want to secure more sensitive payloads. The third piece is that, at least for federal government, we are going to be providing cyber defense capabilities within the cloud. So there has been discussions today about individual organizations having to provide cloud security for themselves. We're just here to say that we're also here to help. So hopefully you'll have a chance to see some of the capabilities that we'll be implementing specifically to provide some of the defensive capabilities that we've already provided for existing IT implementations across federal government. We'll see a lot of that transitioned across to the cloud. So from within the assessment program, I've provided quite a bit of detail here with respect to some of the work that we're doing in that space. I'm conscious that I have a very finite amount of time. If you do have some interest in some of the work that we're doing to assess the individual cloud vendors, you'll be welcome to give us a call, send us an email, or check out the material that we'll have on the website. In terms of some of the documentation, as I mentioned, from an advice and guidance point of view, we're covering off quite a few different areas of advice and guidance. Where we can, we're trying to make sure that this advice and guidance is consumable by anyone who needs it. And certainly, we're looking at much of the advice and guidance that we've seen from other organizations globally, but we're trying to tailor it to a Canadian audience. So you'll notice at the bottom of the page, and we'll be able to provide this afterwards, if you check out the publications portion of our website, you can keep track of what advice and guidance is coming forward. One of the first publications that we'll be issuing are just the fundamentals of cloud security, and we're trying to provide services that will cover off each of those areas, so securing your data, securing your access, securing your service. And that's about it. We have a slide at the end as well with some of the contact information as well. Thanks. Mike.
Cool. Okay, I'm going to talk very quickly about some work that we did recently with the University of New Brunswick and AWS related, not specifically to cloud security, but security more broadly. So as I said, it was between us, the University of Brunswick, and AWS. We needed to get better data to test systems at the unclassified level. We have lots of data, but we can't share it with you, and you can't do your own testing. And a lot of the data that's out there is junk. A lot of people are using the KDD 1999 data set. You might not be familiar with it, but it's really old and not super good. So we documented the problem of we need better data. We contracted the University of Brunswick, the Center for the Canadian Institute for Cybersecurity, to do the work for us. So they've done some work previously in data set generation, and they made a new data set to our requirements. So bigger, better, 500 users, realistic attacks, labeled data so you can do your machine learning development and extracting the features. So again, you don't have to go in and extract your features, they're already there in the data. What AWS did to help was we needed a lot of infrastructure, but we needed it for a short period of time. That sounds like a good use case for cloud. AWS has an academic grant program and was generous enough to contribute $80,000 US to fund this work at UNB. And they have an open data portal where because we want this data to be open for everyone in the world to do research, it's hosted on there. So that's where you can find it. The data is up now on the AWS Open Data Portal. There's a ton of documentation on the University of New Brunswick's website. You can dig into how they did the work and why. And because we're at AWS, that's the ARN. That's the S3 bucket. It is publicly readable, which I get a lot of warnings about every time I look at it. But it is supposed to be publicly readable, so everyone can go and download the data set. It's about 750 gigs of flow data and features related to network traffic for your amusement. Okay, as Sean said, we are the Canadian Centre for Cybersecurity, a wholly owned subsidiary of CSE. This is our contact information. You can call us or send us an email or check out our cyber.gc.ca, and we can help you with your cyber questions. And that's it for us.
Great. Thanks, everyone.
Thanks, guys. So thank you, everyone. If you have any feedback, we'd really appreciate that. So please, there's the link there. Leave this up on the screen for a minute. Let us know. Thank you for your time. Appreciate it.